So thank you and good evening, and thank God it's the last session, okay? So let's relax out, okay? So first of all, thank you Rail Analysis for organizing this event and giving Hitachi Energy India Limited this opportunity to talk about special connected transformers for rail infrastructure. So this topic is I'll take you a step back. We are talking about digitalization, automation, IT, IoT and everything, but let me take you a step back. And here in this topic, I'll be talking about hardcore electrical equipment, that is transformers, okay? So in this topic, what I'm going to talk about is, as I said, transformers. If I may say, railways being a lifeline of India, then electricity is backbone of that lifeline, okay? And whenever we talk about electricity, transformer is there. So when we talk about railways, transformers are everywhere. Let it be the power transformer, which we see in the traction substations. It can be in the form of a substation transformer, single phase traction transformer. Then we have distribution and specialty transformers like rectified transformers. And then we have traction transformers, which are basically the rolling stock transformers. So when we talk about electricity, and yes, electricity is the driving force behind the railways, and in the future we are going to see 100% electrification very soon in India. And with this, there are new challenges that are coming up. So when we talk about transformers for railway application, as Hitachi Energy globally, we have all sorts of solutions available with us. Let it be the DC traction substation transformers or AC traction substation transformers, or in fact the static frequency converter transformers also, which has been implemented in some of the countries. So why do we require all these sort of transformers? See, transformer basically is a very simple static electrical device which primarily function is to step up or step down the voltage of electrical system, okay? But as we know, the application changes day to day, and now Indian Railways is going through another phase, another big leap towards the upliftment of the existing power system or the rail networks, what power system the rail network is utilizing. So it becomes necessary that the special connected transformers, what I am going to present right now, it's not a new technology actually. It was already existent, but now we find application of those transformer connections or technology into our system. So when we talk about transformers, as I said, at Hitachi Energy, we have all sorts of transformer solutions available with us. Let it be AC feeder non-auto transformers, auto transformers, AC to DC rectified transformers, booster transformers, and AC static frequency converter transformers, and the auxiliary transformers. So at Hitachi Energy, we have the complete bucket of transformers portfolio available with us. So let me talk to you, why are we upgrading from the conventional 25 kV system to 2 into 25 kV system. So traditionally, what we have right now using is the typical 25 kV system in the Indian Railways, wherein the power rating of the transformers goes up to 42 MVA, and the feeding or the grid voltage that we are utilizing is up to 220 kV or below, depending on the available grid networks nearby. And when we talk about the majority of the ratings that we are utilizing is 30.24 MVA and 42 MVA rating of the transformers. And at Hitachi Energy, we have all these major ratings, short circuit tested, type tested, available with us, and we are one of the major suppliers for this trackside transformer application. But what is happening is now, as we know, the load as the speed of the railways is also increasing, and so is the load on the track, or the catenary load is also increasing. So what happens is, when we talk about the conventional 25 kV system, what we do is we use a single phase transformer connected to 2 of the 3 phases, and then it is basically powering the single phase load, that is the locomotive. Okay, so what is happening is this creates an unbalance, because normally the grid that is available nearby is a 3-phase grid. And when we are loading only 2 phase out of the 3, that creates an unbalance, and there is a voltage regulation issue that is coming up. And that becomes predominant when we talk about high-speed rails and when the catenary load or the locomotive load is going to increase. So we have then to resolve these things, and there are two possible solutions. One is the passive solutions, wherein we can use the transformer with special connections that we are going to discuss. And there are some active solutions like conventional SVCs and the SVC light. Okay. So in this topic, we are going to discuss upon the specially connected transformers and how it is going to support us in having better voltage regulation, better load balancing between the transformer substation. So there are basically two types, what we can implement and what is now under discussion also with Indian Railways. The first one is the Scott-T connection of the transformers, wherein it's typically a three-phase to two-phase converter of the power transformer, and it has the primary side which is connected to three-phase network, and it has two secondary sides. One is the main and the other one is called the teaser. So basically what it does is the load balancing act, and the load of the locomotive that is going to come onto the transformer is balanced out from the grid side. So if we talk about the connection features, the Scott-T connection transformer is built with two single phase transformer. So basically when you see from outside, it looks like a single transformer, but it has two active parts into it. And these two transformers or two active parts are connected electrically, but not magnetically. They are isolated. So it has its own inherent advantages. Because of that, I'm not going to go into the detail of it. But this helps in balancing the load onto the grid. And how it's going to support is, as a user or as Indian Railways is going to get benefit out of it, is because of this balancing of the load, the distance between the two station transformers or the two substation or traction substation is going to be increased. Okay. So when earlier times the two substations, the distance between the two substations was around 7 kilometers odd, now with the use of this specially connected transformer, it can be going up to 20 or 30 kilometers between the two substations. So this is one of the benefits out of it. Another connection which we have is the dual LV connection, or in general we call it as V-connected transformers. So it's basically a two single-phase transformer connected in such a manner that it's providing the balanced loading on the substation level. So here, the incoming single-phase transformer, or we have the two single-phase transformers, and the connection is done like that, between the LV1 and LV2, we have the 50 kV voltage, but we have the center point wherein one side it is plus 25 and the other side is the minus 25 voltage. So that is the way the balancing is happening, and it gives a very regulated voltage across the system. So when we talk about the specially connected transformers, it is very important to understand how we are designing these transformers. And at Hitachi Energy India, we have a comprehensive software, design software, which has all the inbuilt analytics software. Everything is inbuilt, and so that once we design the transformer, we can do all sorts of analytics. And these are although it's not a new technology, as I mentioned earlier, it's only the connection type that we are changing on the transformer to get a very balanced output, because we are converting from three-phase to single-phase or two-phase. So what we need to do is, because there are special connections involved, we need a greater deal of detailing of the analysis that we have to perform. And we are glad that we have a very comprehensive software, design software available with us, wherein we can put in all sorts of real case scenarios and do the analytics of the design of the transformer. Because these traction transformers or the trackside transformers have a very critical duty. They have to foresee multiple short circuit events, which is not the normal case with a normal power transformer, because the trains are coming and going and the loading is very dynamic. So these transformers have to have a very robust design and the manufacturing process. So as I said, that design is one part of it, plus we also require a very comprehensive, extensive experience to it. So at Hitachi Energy India Limited, we have the backing of global manufacturing footprint. We have around 17 sites at 15 different countries making transformers specially for railway applications. So we bring in all that experience in India, and to support both Make in India as well as Made in India. Why I say Made in India is because we have Global Engineering Center also established in India in Vadodara. So we have engineers who are working on this, developing this technology, and we are supporting the railway applications or the designers worldwide. So we are supporting both Make in India as well as Made in India availability. In India, if we talk about, we have the manufacturing location of transformers based in Vadodara, Gujarat, wherein we have 500 plus employees, and we have around the product, what means a bucket involves both specially connected transformers as well as the normal power transformers and the dry type distribution transformers. And there we manufacture transformers up to 1200 kV class. So you talk about transformers, and at Hitachi Energy India, we have the solution available with us. So totally, we have the total capacity of 30,000 MVA manufacturing capacity annually. So we have talked about the design part, how the analytics is a must, and how analytics will help us out in understanding the behavior of these specially connected transformers in field, in real life. But another important point is how we are manufacturing the transformer. That is also very important. So when we talk about manufacturing skills, we implement the global best practices available with us, and we are learning from others. We implement new things which are applicable to India, and we are adopting the best practices that are available globally in manufacturing of the transformers. So we have completely controlled winding manufacturing facility, because winding is a very critical part of the transformers, and any dust or any moisture entering into the winding or active part during manufacturing is going to impact the life and reliability of the transformers, which is because transformer actually is a very robust electrical equipment. The lifespan is way beyond 20 years. So, but how we manufacture the transformers is very, very important. If we don't take care in the initial state while manufacturing, it's not going to give us the proper lifetime. Another part is we have the specialized air-conditioned zones for the active part assembly, because once the winding are built and it's going to be connected with the, assembled with the core and other transformer accessories, we have to take care that again, there should not be excessive moisture, there should be no foreign ingression of any particles, and after having this core and coil assembly, how we are drying out the insulation is also very important. So we are implementing vapor phase drying, and we have automated oil handling units and other things. And another thing, okay, we can provide the infrastructure, we can provide the machinery, but the laborers or the workman who is manufacturing the transformer should also be skilled. And we are glad that we have a very, very good team of winding manufacturers and skilled labor that has been working with us for a long time. And we maintain and upgrade their knowledge and know-how, proper training, impart proper training, and we keep them updated with the latest technology. And apart from that, all our test laboratories are NABL accredited. So any transformer tested at Hitachi Energy India Limited lab, you can rest assured that it has been tested properly using the most advanced testing equipments and well-calibrated testing equipments. All our factories are ISO certified, and we implement the best on manufacturing practices everywhere. When we talk about footprints of Hitachi Energy India Limited, erstwhile ABB, you might be knowing, now it has been acquired by Hitachi, and now we are Hitachi Energy India Limited. So our manufacturing starts, our association with the railway starts from 2002, and we have been pioneer in supporting Indian Railways in expanding and electrification of the networks, rail networks, and we have supported all sorts of trackside transformers, loco transformers, in fact transformers for the metro application like auxiliary transformers and all. And when we talk about this trackside substation transformers, we have supplied more than 700 units within this span of time, and all among them, the 14 of the design of this traction side substation transformers has been short circuit tested also. So this is just a list of transformers that has been short circuit tested that shows and reinforces the quality that we are adopting at Hitachi Energy India Limited, and how reliable is the transformers that we are manufacturing. This is another analysis. Globally also, we are one of the highest short circuit tested transformer, and we have a very extensive list of short circuit tested transformers. And why I am highlighting again and again this is because short circuit test is one of the thank you. So short circuit test is one of the tests which is which shows the reliability of the transformer and how we are manufacturing the transformer. So we are a pioneer in it, and global presence also. We have supplied transformers for railway application all over the globe. So you can imagine that we have experience, global experience also behind us. And as I said, we use the common design tool globally. So the experience anywhere in the world is going to be imparted locally in India also. So with this, I think I'll wrap up because I'll not take much of the time, and we are having the closing time soon. So thank you for listening in, and please feel free to put in your questions if you have any. Thank you.